All right, welcome to lesson 4 for chapter 16. This is on acid deposition. Learning objective here is that you will be able to describe the causes and solutions of acid rain. So what's making it happen and what can we do about it? All right, just a few success criteria here. So by the end of this lesson, you should be able to describe the primary molecules involved in producing acid rain and their sources, and then describe the effects of acid rain on structures, terrestrial ecosystems, and then also aquatic ecosystems. So acid deposition is the accumulation of potential acid-forming particles on a surface. So we talk about acid deposition, acid rain together. Acid deposition is just those particles being on a surface. Acid rain is water reacting with particles to then create rain that is acidic. They happen together, which is why acid deposition is just typically referred to as acid rain. When dry particles are deposited, an acid does not usually or actually form until these materials are mixed with water. Some acids in the atmosphere result from natural causes like vegetation, volcanoes, and lightning. But human activities like burning coal and using internal combustion engines like in cars produces molecules that forms acids in the atmosphere. Significantly, it's sulfur dioxide and then oxides of nitrogen. So those react with water to form acids. So what we get is we have these industrial places, the power plants, whatever, that are releasing these pollutants. And then they will deposit on surfaces or react in the air with the rain to then form acid rain. That gets in forest ecosystems, lake ecosystems, on the crops, in the rivers, and on buildings and monuments. And it can travel for hundreds of kilometers. So limestone, which is calcium carbonate, gets converted to gypsum by sulfuric acid, and it starts to break down. Gypsum is really easily dissolved. Metal surfaces can also be affected, but we see it really quickly in that limestone. For terrestrial ecosystems, the extent to which acid deposition affects an ecosystem depends on the nature of the bedrock in the area and the ecosystem's proximity to acid-forming pollution sources. So if it's really right next to a power plant, then it's going to have a higher effect. If it's 100 miles away, it's still going to have some, but less. So sedimentary rocks like limestone can neutralize acids, and igneous rocks like granites do not neutralize acids. And then areas downwind from acid pollution are more severely affected. So if the wind is literally blowing it that way, they're going to have greater effect. And then acids also cause changes in the soil that result in the death of trees. If the soil is super acidic, not only can it cause damage to the actual trees, but we're basically killing the soil. For aquatic ecosystems, as lakes become more acidic, there's a progressive loss of many kinds of organisms. The food web becomes less complicated. We want complicated food webs. That is stability, right? We need that diversity. If a food web is becoming less complicated, that means we're losing species. Many organisms will fail to reproduce because it is so acidic, and many others can die. Most healthy lakes have a pH above 6. So they might be slightly acidic because 7 is neutral, but it's above a 6. At pH 5.5, many desirable species of fish are eliminated, so the species of fish that we care about as humans. At a pH of 5, only a few starving fish may be found, and none are able to reproduce. So we have officially killed that aquatic ecosystem. And lakes with a pH of 4.5 are nearly sterile. Nothing is living there. Whoops. So this is a reduction in acid precipitation over time. So this is hydrogen ion concentrations in 1994, shown as pH. So especially over here on the East Coast, big issues. But in 2018, we have had a huge increase, increase in pH, but decrease in that acid precipitation because we have decreased those pollutants. And then this is improvements in lakes and streams over time as well, in the Adirondack Mountains, Mid-Atlantic Appalachian, and then in New England. So we've seen decreases over time. So what has caused this reduction? It's going to be mainly the regulation of power plant sources of SO2 or sulfur dioxide, and then reducing the release of nitrogen oxides from vehicles as well with the catalytic converters. All right, that is the end of this lesson. Please let me know if you have any questions, and I will see you in the next one.